Hello, welcome to Sora Sunbee's calculus lesson. It is currently 10:07 p.m. I just got word that this was due at 10 o'clock, so it'll be 7 minutes late. Well, probably go up at like 11. Probably like an hour late. I don't know if any of my dry erase board markers actually really work at this point. This is old, because I've been using them for so many years. They all kind of die after a couple uses. What else? The calculus AP is tomorrow. I haven't really gotten to study because I've been working on psychology, and I'm probably not going to get much sleep. However, I'm wearing my calculus shirt, and morale is high. So, let's get into it.
The number you have dialed has been changed.
So as it turns out, you can't put a whiteboard in front of a screen or in front of a camera without it being mirrored. So, hey! Here we are, in front of a mirror. What a coinkydink. Full shirt. Okay, so I'm actually doing 2018, question number 1, about the gravel. So the rate at which gravel is arriving at a processing plant, I'm not reading off the screen or anything, I don't know, is by g of t, and we're supposed to find what g prime of t is, or g prime of 5 is, and what that means in the context of the problem. So, yeah, the move now is just to basically do, on your calculator, math, or plug in the g of t equation into y equals, and then do math 8 and plug in for d over dx, and then plug in the y1 equation for x equals 5. And so you get g prime of 5 equals negative 24.558. And this means that because you're taking the derivative of the rate at which gravel comes at the processing plant by tons per hour, it's the tons per hour. And that means it's decreasing by negative 24 tons per hour. For B, we're trying to find out how much gravel arrives at the plant from the 0 to 8 hours. And to do that, we take the integral of the g of t equation, because that's the rate in equation. You're just finding how much is coming in between hour 0 and hours 8, adding it up. So you take the integral from 0 to 8 of g of t using math 9 on your calculator, on your TI-84 in my case, and you get that the answer is 825.551 tons. So the move count in that situation is just to basically the total coming in that time period is just to add it up using an integral, because integral equals area. So at time t equals, for letter C, here, I'll slow this up a little bit. For letter C, we're trying to figure out if the rate at time t equals 5, if the amount of gravel coming into the, processing facility is, if the total amount of gravel in the processing facility at time t equals 5 is increasing or decreasing. So using that, we have to find the amount coming in at time t equals 5 using, plugging just 5 into the g of t equation, and by doing g of 5, you get, slight intermission, my brother came in. So basically, the amount of g of 5 is 98.140 tons per hour. That's the amount coming into the facility at time t equals 5. But at every single hour, the gravel is leaving the facility at 100 tons per hour. So because the amount coming in is less than the amount leaving, the total amount is decreasing at time t equals 5. For T, we're basically trying to find when the amount of unprocessed gravel is at its max at the facility. So let's get to it. So here, first, to find the max, we first have to address that we have to use the Canada's test, because the cow is the Canada's test that allows you to compare multiple different critical points to see when relative max or mins are, and to be able to find the absolute maxes and mins. So first we have to establish what the whole, how to find the amount of gravel in the facility anytime, and that is by finding it's the start plus the integral of the rate in minus rate out, as you can see written here. And so I filled this in, so the amount at any time in this particular scenario, sorry I'm breathing so hard, is 500 plus the integral of 0 to t because like it could be from any time until 8. G of t because that's the rate in minus 100 because that's the rate out. Dt because that, signifies the end of the equation. So you find a prime of t to be able to find a critical point, like to see like a max or min for the candidate test. And so you find that a prime of t, which is the total amount, is g of t minus 100, which is rate in minus rate out. And because we want to find when it, for the derivative, it's when it hits 0, like crossed over between negative or positive for the f, like the a prime. We want to find when the rate in minus rate out equals 0, because that would be like on the graph when it equals 0. So you find that g of t equals 100, and when that's, like when g of t equals 100 is when t is 4.923, and so you plug 0 and 8 into the candidate's test for t, because those are like the ends of the starts and ends of the equation, and you also plug in 4.29923 because that's a critical point because of the a prime. And so you plug into the original a of t to find how much there is at any given time. So for 8, 0, and 4.923. And by doing that, you find that the max amount of gravel at any given time is at t equals 4.923 at 635.376 tons. And that is the absolute max. Thank you.